We're still in the chapter on physical equilibria, which means that we're still in a chapter in which delta G is equal to 0. However, we are transitioning away from a first few lectures in which we were looking at phase transitions. By that I mean you took a pure substance and you changed it from a solid into a liquid or a gas into a solid, but it was a pure liquid that you were working with. We learned all about these phase changes and all of the different kinds of thermodynamic sorts of calculations that you can make associated with it, and also a lot of the kinds of observations that you would make as you looked at those types of systems. Beginning with this lecture, we're going to look at what happens when you take pure things and you mix them together. Delta G is still going to be equal to 0 on the other side of having done this, so this is still physical equilibria in action. But it's the physical equilibria that's associated with what happens, not with something pure, but when things are mixed together. Let's think about what these things are that we're trying to mix together, and we'll think about it in the context of having differences in phase. So we have three phases, basically, solids, liquids, and gases. And when we talk about mixing, we can think about mixing, well, all the combinations of these. So we can mix solids with solids, solids with liquids, solids with gases, liquids with liquids, liquids with gases, and gases with gases. So that's 6 different possible combinations of things that we can mix together. The question is, which of these are actually interesting enough for us to think about? Let's think about the 2 extreme cases, mixing solids with solids and gases with gases. When we think about mixing solids with solids, the question we have to ask is, are we getting some sort of physical process to occur that actually results in some kind of energy change? You would expect this to happen, for example, if you had one solid and another solid come together in such a way that there were these intermolecular forces that were established between them that weren't there before. We don't typically think of solids doing that. Certainly they can, but for the most part we think that if we throw a sodium chloride salt crystal together, for example, with a sugar, that there's not a whole lot of energy exchange that's taking place to form something as a consequence. Now, that isn't always the case. If you remember, one of the really famous demonstrations I do is one in which I mix together 2 compounds to make an endothermic process happen, such that I freeze a block of wood to a beaker. And in that particular case, obviously, there's something serious going on, and in fact, it's a chemical process. But for the most part, we're going to ignore solids interacting with solids and the mixing associated with those. Same thing over on the other side, where I'm looking at gases interacting with gases. Certainly, there are gases that are capable of interacting with other gases, but we make the assumption that if ideal gas laws are in action, if we're using kinetic molecular theory, then when one gas molecule bumps into another molecule like this, they bounce off and they've had no interaction to speak of. So we'll rule out looking at gases interacting with gases. What we are left with is in the middle. It's what happens with liquids. It's the mixing that takes place with liquids, either solids interacting with liquids, or liquids interacting with liquids, or gases interacting with liquids that'll be the subject of this lecture.